Yes, Amy. Mhm. Yeah. Okay. So once you go to the AII, so here you can go and click the object detection one. So the tutorial will pop up. So we are going to learn about the object detection today, right? So during the basically the third lecture, we have trained the model to detect the vehicles, right? In the Jupyter notebook. So where we have observed we cannot run for a long iteration, so therefore we ran for only 10 iterations with different classes of images, and we were able to detect a certain object correctly. Only 15% accurate came, right? So, but what we have done actually over there, we have cropped an image of a car and say this is a car, right? And we have cropped an image of a van and we said this is a van. So like that, we have collected 100 cars images, we have trained for 100 van images, multi-purpose vehicles, sedan vehicles, all are individual images. But in certain images, we have also seen it's classified as truck, but with the truck, there is a small car also, right? So in that case, the model get confused while learning. So, but when you take the Tesla car, does the Tesla car take individual image of a car and say this is a car, this is a van, this is a multi-sedan vehicle? No. It's one picture, everything's are classified, right? It's one picture, every objects are identified. So what we have done earlier in third week, fourth week is image classification, right? You take one image and you say what is over there. Is it a lorry or a car or a sedan vehicle or something? Today, what we are going to do is object detection. So, how the object detection is different from the image classification. For example, if you take this is the car image, let's say one camera, so you can see in one single frame there are multiple cars, van, trucks, and everything is get detected, right? Multiple things are get detected. So this is object detection. So what is the difference between the image classification and the object detection? Is image classification mean, for example, if you send this dog image inside to an image classifier model and ask, what is this? The trained AI model will say, this is a beagle dog, right? It's a beagle breed dog. So then it will say, the label is beagle. But if you closely notice here, the beagle have a bowl, and this has a chair, and the foot relaxing table, and there is a sofa. Everything is there in the image. But the image classifier is only trained to identify this beagle. So the whole image is identified as beagle. But the object detection, if you send an image with a beagle and a person, right? So the person is going to get detected. It's one image, and the dog also going to get detected. See, so it's a 95% dog, 89.95% a person. So if we train the model to detect cupboard, if we train the model to detect shoes, socks, then it will be able to detect that also in the object. So this is the difference. Image classification, it classifies the whole image as one label. Object detection, one image into multiple labels, what we are going to train on. For example, this image is trained on cars, trucks, small vehicles, whatever the vehicle type, right? So then if you take an image and send it through the pipeline or the image object detection pipeline, it will be able to put a box and say, this is a car, this is a lorry, this is a van. But if is an image used trained with the classifying AI model, then once you put this image into the classifier, it will say it's a traffic. That's all, right? It won't say, because how we train the model. Basically, in the fourth week, we have trained sedan, multiple purpose vehicle, small car, big truck, and everything. If you put an image of this one into that classifier, it won't do anything. It will get stuck because it may say false results, because we didn't train the model with multiple cars in one picture. We have individually put the car and we have trained. So that is image classification. So today what you are going to learn about is in object detection. Object detection means if you take an image, it will be able to identify the certain objects that we train the model for. So it cannot detect a chair without saying AI, this is a chair, right? You should train the model, okay, this is a chair object in an image. So something like that. So now we will deep dive. So how it does actually, how the object detection works. If you take a image, so for example, let's say we'll take an image here. So how you identify the objects? Let me know what are the objects you can see over here. So you can label a fan, uh, books, you can label a TV, you can label a chair, uh, sofa, and flower vases, and there are paintings, and there are walls. So how our human brain do it actually? At a look, you can label everything? Sometimes. But if there are many objects, at a look, you can label everything. So what you do is, you scan the image, right? So first what I did was, I go to this point, I go to this point, and I start to scan the image like this, right? Like in a way. And I identify, okay, there is a painting, there is a painting, and when I come here, there is a fan, when I come here, there is a curtain, then little bit down, there is a flower pot, and there are books and everything. Here, when I come here, there is a painting, there is a kind of a ornament hanged in the wall, and when I come down, there is a TV. Like that, I'm scanning the image, right? So the way my eyeball is in the image in a second. That's how I was able to identify the object in the image. So what we said at the beginning, AI is in a such a way, it mimicking the brain and the human activities. So we should also make sure the AI also should be able to do that to identify the objects. So the first technique used to identify objects in an image is called sliding window. So we set a sliding window, and we move this window size. Maybe it can be a fixed window, maybe it can be a different size window. So from this corner, you try this way and this way and this way and this way. You come along all the way and identify the objects. But there might be an issue, because when you are coming here at the front end, there it might be detected as a car. And when you put the box in this middle, it will be detected as a car. In this area, this is detected as a car. So multiple boxes can link and say that is a car. Because for example, if I take this image, if I slowly go closer and do like this, I can detect the fan and again a big fan picture and a small like that, right? So how I combine it as a fan? So my brain does it automatically. So how the AI does is AI use a window. So if you see, if it's a sliding window, the dog will be boxed by multiple boxes because the way we slide, it's the same fixed sliding window. Here they are using. So, but these sliding window altogether should say this is a dog. So we can't, like if I upload a image and it say how many dogs are here. So if we slide and put multiple boxes like this, identified as dog. So this model will say there are 1, 2, 3, 4, 5, 6 dogs in 1 image. But actually we have only one dog. So what we do is we do a cleanup. So we find out, okay, what is the exact box showing the dog. So that is a kind of mathematical model that we do to clean up the thing. So the second thing, right? So how I can identify the objects, the tiny objects in this thing. If I want to show this image and say, okay, what are the things? What I will do is, can you see what is over here? There is something dark right here in this corner on the table. We can't. So what I do, I zoom in, right? When I zoomed in, I was able to detect it's kind of a smart device with a couple photo in. Can you see it when you are here? No. Then I zoom here. There is a photo frame. Then I zoom up. Then I zoom here. And this is a flower vase. When I zoom here, so there is a pillow. So what I do, I zoom in, zoom out, zoom in, zoom out, and I was able to identify the object with the image, right? So that means we can also make sure the AI can also, or the machine can also do the same to identify the objects, right? So the second way of detecting the objects in the object detection model is image from it. Image from it means to go here, you can see an image from it. You zoom in, zoom out, zoom in, zoom out, and you identify different objects, right? So the two way that we identify, maybe at a time we look, if there are very less number of items, you will be able to, one time you look at it and you just close your eyes and you will be able to tell. If multiple objects are there, what you do? You scan through the image as a box one by one. Finally, you say, okay, these are the objects there. Or the other way, you zoom in, zoom out, zoom in, zoom out, zoom in, zoom out, and you say, these are the objects identified. The same approach we are going to work with the object detection method. So the first one approach is called sliding window. So picture that image as a puzzle. So it is going to move like this, as I said, and scan for the objects that we have trained for. If you train for a dog and a person and a chair, whatever the image you upload, the model will go through that image only looking for those three objects, right? Because it's trained for only three. Other objects, they don't care, right? The second one, image from it. Zoom in, zoom out. Different point of view, it's going to look at the image and it's going to say what is that. And the other one approach is CNN, convolutional neural network. What is that? We have learned during the last lectures how we have classified the handwritten characters using convolutional neural network. We just input a picture image, pixel, and we send through multiple convolution layer. And finally, from that layer output, we classified what it is. So if you remember only the pixel input that we have flattened and gave, we had 728 pixel neurons, 512, 512, and 10 as an output. It's a very simple neural network. But when it's come to CNN, we get the image whole as an image and we convolve and we get the output. We max pooled to reduce the size of the matrix. We convolute and get the feature. So that is an image feature automatically extracted through a certain type of mathematical operation. Finally, if you see the neurons at the classifier level, only 512 neurons we had, not 3 layers, because all the feature extraction step is performed very nicely before. Then only 1 layer of neuron is enough and the other one is output neuron 10. So it's classified better than the two hidden layer and 4-layer neurons. Why? Because of this convolutional network. So there is another approach using the convolution neural network. Why? Because the CNN can look the whole picture at a time. Unlike flatten and checking one by one, it will be distorted the image if you flatten, right? You are flattening the pixels. So, but if you take the image as a one point, you can do that identification. So there are certain techniques called convolutional neural network. So one of the things that we are going to learn is a convolutional neural network based approach, which is called YOLO V5. So YOLO is an object detection mechanism constructed based on a convolutional neural network architecture, right? So that is the one that we are going to do. So after that, we have trained the model to detect the decisions. So then the decisions will be made. What are the objects over there? So in the decision, you will see these kind of multiple boxes over there. Dogs, 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 right? 5 dogs in one dog picture. Then what we need to do? We need to do the cleanup. So for the cleaning up, what we do is we use a mechanism called non-maximum suppression. Right? It's a mathematical model. So we select all these boxes and we suppress all the irrelevant boxes which is not highlighting most part of the dog using a mathematical operation. It's just multiplication and getting the max out and just cancelling the rest of the minimum value, right? So we don't want to go into detail such cases. So the name of that thing is called as non-maximum suppression. Non-maximum suppression. So avoid double counting and keep only the best one. So these are the steps. So what we do, first we take an image, we go through the sliding window approach or the pyramid approach or the CNN approach, 3 approaches. Then we find out the objects. After finding out the objects, there might be a chance one object is surrounded by multiple boxes because the AI sees in that way through the box, sliding box. So then we clean up the boxes and say, this is the box, that is a beagle, right? So this is the object detection. So if you go through this one, here also the same thing. It go through a scan, through a faster image, and it put the boxes over there in the car and say it's a car. So it's a real-time video. So now it is working in a real-time video. For example, if you take a kind of a Tesla car, right? Tesla car, it should be real-time because when it's driving in 120 kilometer per hour on a highway, so if it detects a car, next millisecond, it should detect as a car. So it should be fast enough to detect the object. So but we are going to use CNN. So CNN is a very high loading model for the CPU and GPU, right? So what the Tesla car has is, for their object detection model, they have their own high-end GPU. It's NVIDIA one. So they are using a higher GPU powered object detection hardware tool to do that. So once the live feed is coming in, it will be able to detect very quickly. So in couple of nanoseconds, it scan all the thing and put the boxes. Next nanosecond, like that. In nanosecond range, it's do that. So in that case, we will be able to avoid the accident. In this also, if you closely see, the cars up to this level are marked. The cars coming from here and the corner, it was not detected. Right? Because we have not trained for those kind of far away images. When the image we are looking at from far, we will not be able to recognize. But what we do when it's coming closer, we set the threshold. There are multiple ways of mechanism to detect the thing. So the object detection is very important when it's come to analyzing many things. So I'm going to say some few examples. One is the Tesla driving car, obvious example. Second, in the agriculture, there are certain projects our students are doing to identify tea leaves to pick up, right? So now the human goes, they pick up the tea leaves and they put it in the basket. They know which tea leaf to pick up. But now, if you want to train a robot, right, to automatically walk through the tea estate and pick the correct part of the tea leaf, so how the robot knows? Everything is green, right? So we need to train the robot to take an image and identify those tea leaves on the tree. Then the robot goes and will be able to pick it up. So that is an object detection which identify the correct tea leaves to pick up, right? That is another object detection. Other thing that we have used it in the object detection in US, in US, the farmer means farmer is the richest person in the US. He will have million, he will be a million because definitely their farming land will be like thousands of acres, right? If you see thousands of acres land will be managed by maximum 10 people, maximum 10 people because all machinery automatical watering system is there. Only the farmer comes and he drive and get that thing. All machinery is driven farming. The productivity is high. But the issue is when they are looking for the weed, it means that other plants grow in between the desired plants, right? So we have to kill them. Otherwise, it's going to suck the nutrition from the thing. So what they do is they use a drone. So the drone flies over the field in a systematic way, scan the images, right? So when it's going in the top, that detection method is trained to detect the weeds. So it'll be able to box the weeds from that image. So once farmer come here and look at, okay, there is a weed over there is a weed over there, send the robot or the he goes and remove it out. So that kind of farming application is possible. Other one, disease detection in plants. In agriculture, it's widely used. So you identify the object, you put a place for the diseased area because we don't know it's a leaf. In a leaf, this plant is diseased. So the diseased area should be boxed up for the AI model to see what kind of disease it is. So disease detection. So there are multiple ways of in practical world the object detection is used, right? So this is going to be a ultimate tool for you in many applications. But when it's come to real time, you know the complexity now, right? Earlier we sent one image, what is this? Now we send one image, what are the items in these? So it's a huge task for the AI. So we should have a proper capability hardware system, GPUs to accommodate these needs. Okay. So now the image classification steps are clear, right? Like how the human identify and how the machine we trying to identify. The same way, nothing else. No rocket science over here. All right. So now we are going to talk about YOLO V5. So now what is the issue when it's come to the sliding window approach and blah blah? It takes time. Computationally, hardware get loaded and lot of other issues might come. But human also look at certain things at one time and say, these are the objects over here, right? You can look at one time and close your eyes and you can say these are the objects. So YOLO is a model which is trained based on that. So you are not going to slide through each window. You are going to look at, send all the image. At the same time, the YOLO is going to tell what are the objects in it. So that's why we say you look only once version. YOLO V5, right? There are V10 also there. V9, V10 is the latest release. So what is the issue is YOLO. They release YOLO V1, very good, high computational power. They reduce the system architecture, reduce some convolutional layer. This is the input image as an image pixel, not flattened layer, and go through convolution layer 1, convolution layer 2, 3, 4, like that. After that, this output backbone will be connected to another neck. This is a different architecture. We don't want to go into detail. Finally, the head, then the BB boxes will be boxed. So this architecture, you don't want to worry too much. So this is a simple architecture for V5 having multiple convolution layers. That's all, right? So we don't want to go into detail how these backbone and neck and head is going to perform a mathematical operation. So these are convolution layer. Neck is kind of a mathematical operation. Again, a kind of a convolution way. Head is also in the similar manner. Finally, the boxes will be done. So the way we do, look one time and identify all the objects the YOLO is going to do. So that means it's going to be really heavy as well. So what are the version improvement is the speed of detection. So YOLO, if you take YOLO V5, pretty much slower in detecting in real time. So when it's come to real-time monitoring application, in a photo, fine. But if a vehicle is moving in at 120 mile per hour, kilometer per hour, Tesla, you have to very fast. So they do a different algorithm, not the YOLO one. Tesla have their own algorithm to detect the these objects. So we are going to use a YOLO, which is a pre-built model, but it's not trained, right? You have to train on your thing. So this is model that they have trained, tried, it performed better. So these many convolution layer, these many, this is the mathematical way of neck, this is the mathematical way of head, and this is the output. So as we said, how I know for the character recognition, how many convolution layer that I have to add? I don't know, right? I just experimented it, right? I added these things, and I tried it. Maybe the object character recognition can be, handwritten character recognition can be done with less number of convolution layers as well. I don't know. I just experimented. So like that, they have experimented, the YOLO team experimented multiple times. They come up with a good architecture, YOLO V5. After that, YOLO V6 come, V7 came, V8, V9, V10 now, right? So V10 is super fast and super performing in micro object detection as well. Very small objects, little blurred, it will be able to detect, right? So that is the YOLO. So we are going to talk about the YOLO. So now, in the object classification, what are the inputs that we gave? We gave a car image labeled as car. We gave a lorry image labeled as lorry. We have the sedan image labeled as sedan. But in the object, we have one image, all the vehicles are over there. So you can't tell the model, okay, these are individual objects, go and find this thing. No. So you should teach the model how to identify those cars, trucks, lorries, those things in that big picture, right? So our model also, our data should be like this actually. Our data should be, if this is the big image, if this is the big image, so I need to say this is the image and this box specify a car. This box specify a truck. This box specify a lorry. This box specify a bike. Okay. So something like that. So take an image and I have to box it, and this is going to be the training data for my YOLO V5, right? So this is how we have to create the training data. Unlike we gave for the classifier lorry, car, blah, blah, that's easy. But now the data preparation is going to be a painful process, because you take an image, you have to identify each object and you have to box it and say this is a car. And these box coordinates will be taken as an input for the YOLO model. Okay, as an input. So this whole picture and these individual box coordinates will be taken as a thing. So the first step, we are going to do some data collection. So what we need data collection for training. So it's going to be a fun work. So for that, there are multiple tools available in the market. So there are label image, open source software. There are multiple softwares to do this data collection. So in this tutorial, we are going to use a model called RoboFlow. RoboFlow. Basically, the RoboFlow, what they do is they have created a platform where you can train your model in the YOLO itself. So, for example, I need to detect certain objects in a farmland. Let's say that weed detection thing, I'm going to train my model on. So you go take the images and put those weed images here and there, and you train the model itself. So that YOLO is a powerful platform to create the data set, to train the model, RoboFlow, right? Train the model and get the train model output. And you can use it as a API key also, right? But in this case, we are going to only collect the data and we are going to train the model in our platform here, Google Colab. So let's go to the YOLO Flow. So if the common data set that they use to train the YOLO V5 is COCO data set, right? COCO data set or Ego Hands data set. COCO data set has these labeled car images, birds, chairs, tables, certain objects, real like most common objects. So we will see here an individual image is shown, but those are boxed images, right? So we are going to see how we are going to collect the data, right? Let's create the data set with RoboFlow. If you click that one, right, you can go to the RoboFlow page. You might need to sign up. You can sign up with your Google account. right? You can, where is the sign up button? Sign in. So this is a open source platform. You can use it for free of charge for data collection and these things. Can you get it? Yeah. Wait, sign up. Yeah. You also? Really? Give me a second. Others can access V6? You cannot? It's a self enrollment is not there? Cannot be. Who is having that issue? You. You also? Yeah. Continue. Can you go to categories and go to, yeah, you cannot enroll this. It's not locked ID. Give me a second. Okay. I'm going to log in. Whoever logged in already, just log in. I just need that. Yeah. Good morning. So there are few students having some difficulties to self-enroll for the week 6. Can you just look like if you have a computer, can you check? Ah, okay. How yeah, how to do that? How to do that? Do you know? Yeah, edit mode. Okay. Yeah, yeah. Participants. Yes. Okay. Yeah. Uh-huh. Okay. I will do that. Okay. Okay. Bye. Okay. So, okay. So we will, whoever got signed in, please like do that thing. I will make sure that's going on. Only,
annotate the data. So as I said, what we need to go, click here, drag a box. What is this one? Is it a car or a van or a truck or a lorry or a motorcycle? It's a van. I'm going to specify it as a van, right? And save, enter. That is one van boxed. And I'm going to label the cars now. So I'm going to label the car. So here I can go, box it out, right? And I'm going to go and say this is a car. And again, go to the next car box, label it, this is a car. And label it, this is a car. So I'm going to set what are the cars available, what are the vans available over here. Just, it can be overlapped, it's fine. So you can adjust that also. So now I am collecting data for the model training, right? I'm labeling the cars. Save, enter. So there are, you can see how many cars you have labeled in the left-hand column. So here also I'm going to say a car, right? Okay. So this is a box type enter. So certain time, there might be overlap. So how you are going to label this car specifically, right? If you put a box, it's going to overlap with that thing. Ne? So what we can do that, we can go here and we can put the point, right? Like this. Okay, this is a car. So there is another project going on in Morotua, automatic strawberry plugging robot. Automatic strawberry plugging robot. So what is that? It goes through the strawberry farm and it's pick the ripe strawberry. So the model is training to plug the strawberry at the right spot. So how they label the strawberry is through this way. Dot, 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 dot. Because we don't know how the thing is going to be. Then when you enter, then this is a car. See? The car is labeled in a such a way, different way, because we can't expect all the objects to be in the same shape. So for example, the strawberry is like that. So we know to cut the strawberry in a particular spot, you point cloudy. So there are multiple options. I'm going to do only these boxes. Is easy for now. So we'll take the boxes. Car, and this is a car, and this is a car. Okay, and this is a van. So I'm going to label the van. Only cars and van are there. So I will label it as van. Okay, all right. So this is also a car, I would say. We don't want to label everything, right? So, car. So then save enter, then you press escape. So now we have labeled all the images, whatever need, maybe we can also label this as a car if you wish, right? And save. So now we have labeled all the images, car, car, van, van, everything is labeled. Then I'm going to press escape. I sure want to exit annotation mode. Okay. So then you can see this image is labeled right, right? Then I'm going to the second image, going to do the same. This is a car, right? And this is a car. Save enter, and this is a car. Save enter, this is a car. So like that, in your images also, do the save enter part. Save enter. Save enter. Save enter. Here also all are cars. I will just label it. Okay, cars. Save enter. So once I labeled it, I'll press escape and okay. Go to the third image. Here also I have cars and a van. I just put the thing. I'll put the car here. Save enter. And the car here. Save enter. And the car here. Save enter. And there is a van. So I'll put this as a van. Okay. So how you carefully box it also matters. Now this box is a very bad box because I boxed this thing also, that grass also, the tree also as a van. But it's okay for now. Just while you are labeling, what you can do, you can zoom in and label it, right? Clearly. So here I'm going to put this as a car. Save. And here is a truck. I'm going to put it as a truck. I mistakenly labeled as car, truck. Okay, done. So like that, this image is also labeled escape. Okay, going to the next image, and there are certain trucks available. So I'm going to label these as trucks. Okay, not trucks, it's truck, right? I need to save it as truck. Okay. Then this is a truck. Save, and this is a truck. Save, this is a truck. Save, and this is a truck. Save, and this is a truck. We don't want to go far. That is enough. And this is a car. This is a car. This is also a car. All right, I labeled it. Okay, go to the next image. I'm going to label a few images. You also label all your 5 images because we are going to download and see it. Truck, save, enter, and this is a truck. Huh? Yeah. Yeah. Give me a second. No. That's automatic labeling. Yeah. Okay. Downloaded only one image. Download vehicles on the road. So then only you can label. So now it will come as an image specification. So yeah. One vehicles on the road. Yeah. Then one is enough. Just this is for practice. Anyway, we are not going to use this data set for the training. So this is just for practice. So then go there and label the car. I'm going to label it as a car. Save, enter, and this is a car. Save, enter. This is a car. Save, enter. This is a truck. Maybe truck. Save, enter. This is a car. Now you are getting it right. How the data is created. It's not an image classification. It's an object detection. So I am defining the objects. So this is a car. So you have to. It's a labor intensive step. So in the one Australian project, what we have done was we have trained the YOLO on chairs, tables, and everything. Chair, table, car parking spaces, and everything. So that took a lot of time to do this data creation because we have to specify what is a car parking space, what is a car, everything need to be classified, right? So the data collection is a time intensive step. So I will just put this as a truck and we will finish this training. Data collection. Okay, then I'm escape. Okay, then I'm going to come to the other one. There is a motorbike. So I'm going to put this as a motorbike. Motorcycle. Save. And there is a car. Let's say there is a car. Save, enter. Cool. So now we have collected the data. So all the images are annotated in such a way we have done. So these images are very blurred images which I have downloaded. But if the image is very good quality, then the data quality also very good. So now we will go here, save and continue. Right? So here, once you are going to save and continue at the top, it will ask split images between train, validation, and test data. Add all images into the train set. All images to validate set. All images to testing set. This RoboFlow is good because it knows we are going to use this image labeling for the YOLO algorithm. So it will be split according to the train, validation, test. So now we will say, okay, just for now, I am going to say all these images are for training, right? And I'll continue. Then once I continue, it'll upload all the files. Okay. Then you can go here and you can resize the thing. So here the images are resized into 640 into 640. So you can edit it and change this also into stretch to 640 into 640 or 220 into 220. Why we need this? Because we have to make sure we are aligning with the input. Otherwise, different size of images goes in, AI get confused. So we will put it as a 640 into 640. Then I'll continue this one. Augmentation, I will just skip this part right now. We will come back again later when we are doing the later part. So continue turned off and create. So once you create, the data will be ready. So now you can export the data set. So you can download a zip folder or you can download the code to access this data set from the RoboFlow platform itself. So you can do it in two ways. You can label it, you can download the data set to your computer and do the training, or else this show download code option we will use in this tutorial later. So it will automatically get all the data from the RoboFlow without download, right? So there are two options. For now, I will download it to show you. Select the format. Select the format. We are going to use YOLO V5 PyTorch, right? PyTorch is a compiler. TensorFlow is a compiler library, right? So which makes sure whatever the code that we code it in the computer is how put into the hardware, right? So now you can continue, then we will be able to download the file, right? So you don't want to do it because I just want to show how the downloaded files are going to look like, right? So now I downloaded the file. You can have a look at here. I'm going to extract all. Okay. Okay. This is the thing. So now if I go there, these are the README data. There are data sets. We don't want to worry too much. I only said keep this data as a training data. So I only got the training folder, right? Only the training folder I got it. So here if you see images, these are the images and these are the labels. Labels are text file. So I'll go to the images one, image vehicle image one now. If you see there are van, car, all the things are there, right? So now this is the thing that we have labeled. If you go back to the labels and open the vehicle one label, here you can see 3, 1 point, 2 point, 3 point, 4 point. What is this one? What are these 4 points and this number 3? Do you remember in this figure, I have marked 2 vans, this as a van and this as a van, right? Rest of them all are cars, right? So the YOLA model give the label as 3 for the van. So if you see there is 1, 3 and there is another 3. As I labeled 2 vans and rest of them are cars. So car label is 0. Why? We can't say car. We have to convert it into a number. So YOLO, this data collection RoboFlow does it automatically. So now this is number 3. This class is a van. And these 4 points are the points of this is 1, 2, right? So we can draw a box with 4 points. So that is the 4-point box over here. Clear? Right. So now you can see all these 4 points over here. But if you come here, certain thing have 1, 2, 3, 4, 5, 6, 7, 8. What is that? Do you remember I used certain dot format thing, right? So all those are the dots that I have created. It's a car. If I draw a box, it's 4 points. If I draw a point cloud based stuff, it's a different thing based on the point numbers that I'm classifying, right? So these are the data. So now this input is going to be a data for the training YOLO model. And this image is also going to be a data input for the YOLO model. So now we have the image and we have the location saved as a text file where this car, van and everything is located. So if I give you these two, can you locate it? with the coordinates, if you go, you will be able to draw a box around van, car, and everything, right? Okay, this is the image. So these are the coordinates of the object. If I give you, you can do that, right? So the same thing we are going to train the YOLO. So now if you go to the image, maybe 6, that is going to be 2 classes, 1 and 0. The motorcycle is given as class 1. So if I go to the image 6 here, let's go here, go to the image 6, image label, image 6, vehicle 6. I only labeled a car and a motorcycle, right? So if you go to the label 6, label as a square, 1, 2, 3, 4 points are there. This is for the motorcycle, and the 0 is given for a car. Already we know that 0 label. So vehicle 3, we had some trucks. Am I right? Let me see where the truck image that I have used. Vehicle 4. Yeah, vehicle 4. So let's see what's the RoboFlow is given for the vehicle 4. Vehicle 4 label. I'll go there and check. So I have a couple of lorries. So the lorry is given as a label 2. Right? So this is the image. You are getting it, right? You are following it up with. So this is the points. These are the points for the corner points of the square. And this is the label. 2 is a lorry. 1 is a motorbike. 0 is a car. 3 is a van. Right? So that's how we have labeled the data. So now we can use the data directly to train our model. So is that clear how the data collection is made for the object detection? Yeah, go ahead. Zip file. Export format, I just downloaded as a zip file. So this is not needed right now because I just opened to show you like that. But in our platform, we will use the code format for different data. I know certain people will select different images. So I have found an open data set. We are going to use that for the training, right? So they also have done it in this similar manner. Upload the image, labeled all these data. And this is a car, this is a van, like this. Now they have a text file and an image. So these two are the things going to go into the YOLO training in. Clear? So for example, if you want to train plant disease, so you all the tea leaves. So you take an image, multiple image of tea trees and label that green color that needed to pick up items, right? So that leaves ready to pick up. So then once you upload that image, then you know this is not good, good. Ready to pick up, not ready to pick up. We will label like that. So 2 classes. When you upload an image, it will be able to identify ready to pick up item. So that's how the YOLO works. So this is how the YOLO data set is created. Not only YOLO, any image class object detection model. Clear? Cool. So we will go back again to our tutorial, right? So now YOLO V5 is an open source project where somebody have trained. Open source mean there's a platform called GitHub. You might have heard about GitHub. So you can create your own GitHub. You can put these models to actually connect and upload your projects and everything. If somebody want to copy your project, they can copy if it's it open source. If you want to lock it for yourself, you can keep it as your personal. You cannot, others cannot clone it. But it's a data storing element. So earlier days, these publications for the professors, right, in the computer science, publications, journals, conference, those made a huge difference. Even if a student is want to get into a higher studies, PhD, MSc thing, in the computer science field, they look for the conference papers and the journal papers earlier. Now nobody cares conference and journal. They ask for their GitHub account. So the supervisor go to his GitHub account and ask him to add him as a viewer or thing. He go through the projects that the student has done. So based on that projects, the job is offered for the computer science project. Even the higher studies are offered for that thing. So no publication is going to make a huge impact in the future for the computer science and engineering field because they see what are the projects that you have done. The GitHub have a ranking criteria also. They give a number for your ranking. You are number 6, number 0.5, something like that. So based on that, how good you are will be ranked. So that is a very good strategy because papers anybody can write. Anybody can means if you do a research, you can write. But the project means you have to really involve in the project to write the code. So like that, the GitHub is becoming as a popular tool. It's run by Google. So you also can start up a GitHub account and save all your code, push the codes to the thing. So the good thing is you can write work on your environment laptop and you can upload the code by using one command to your GitHub. So you don't know to drag and put, there's a very easy features added. So now what we are going to do is we are going to get the YOLO v5 open source code to our data, because we can't create this hard model by our own because it's classified by the YOLO v5 people. So what we are going to do is we are going to use it. To use it, I'm going to say git clone the v5 their GitHub page. What it will do is it will go to that page, download it and save it in my side A. See, you can see the YOLO v5 is downloaded. If you download, there are certain things, there are export requirements, train py, there are many other files over there. We don't want to worry about too much. So one file I would like to worry a little bit is the requirements, right? Requirements means, for example, to visualize the MATLAB plot, what are the libraries that we have to install? We have to install matplotlib, right? So that is a requirement to visualize the data in the platform. So similarly, these people have put all the requirement installation inside the requirement file. This is a standard procedure. If you are working on an open source project, you don't say install these libraries. You put all the required libraries into a requirement text file. Then you call that text file and install it. That means all the requirement files will be installed. So now we are going to do that. So what I'm going to do is we are going to go install all the requirement file over here. So for that, I'm going to run this one. This is cd YOLO v5 means I am getting into this folder because the requirement file is actually inside this folder. So now I am in the GitHub environment, outside the environment. cd YOLO v5 means I am going inside this folder right now. I am inside this folder, right? cd. So after going there, I'm going to execute the installation of the requirement file. So pip install qr requirements.txt. This is the command for that. If you go there, I can find the qr requirements file. Where is that? Just I have, yeah, this file, all the libraries, all the models that they have put over here will be installed automatically, right? So, right. So we'll close it. We'll run this one. Once it run, it will take a couple of minutes or seconds. Then you can see it started to download. It will start to install whatever the things that is downloaded. So this is a YOLO v5 model. So if you see, almost all the projects run in Sri Lanka, agricultural, any testing, everything, it's run on YOLO. YOLO, different versions. So instead of git clone YOLO v5, I should, if I want to work with YOLO v6, I should get with YOLO v6, right? Download the v6. If I want to work with YOLO v10, I need to download the v10. So again, in the RoboFlow, you have to make sure what version you are going to work with, and you have to select the version while you are doing the data creation, because different models takes the different input way, right? So the data will be created according to YOLO v5 or v10, whatever you are going to work on. So right now we are going to work on YOLO v5. So I created the data according to the YOLO v5. So again, we are not going to use the same data that we have created right now, since many people have got many other issues. So let's see. So there might be an error comes up. So that's not a big issue. It's a Google Colab version issue, but it won't affect our thing. So I will just run it again, so it will go away. Okay. So that will not affect our training much. Run again, then the error will be vanished. So it's not a big issue in our training process. Right. Now, what I need to do is I need to get the data to the platform. So as I said you earlier, we can download it as a zip file, put the zip file into this place, extract the zip file and put this place, and we can do the training. Or else we can access the whole data set directly from the RoboFlow platform as well. To do that, we have to go to this vehicles road traffic for data set. So this is an open data set created by a public domain people where 45 vehicles labeled and around 4058 images. Can do that in this class. So what we will do is we will use this image for our training purpose, right? So the same thing we have how we have labeled right now. These people have labeled 4058 images in such way which have 45 vehicle classes: car, van, lorry, motorbike, maybe many other vehicles, right? So now these are the thing, right? You can explore the data set by clicking it. So it will show what are the data set. Yeah. Yeah. How to get that thing, eh? So yeah, which yeah, this is a training data set. So it's already created. So we are going to use that. Yes, already. Yeah, I'll tell you. I will come to that. So now what we need to do is these are the images over here. You can see so how they have labels. So these are very clear images. You can just open up one and see how they have done it, right? See. So the RoboFlow allows another way of doing is in a video. So we take a screenshot. See if you see this one, this is a video. Basically, this is a video. It's running here and there, and they are labeling it on the spot. It's at the same spot, right? So this is also possible. You take a real-time video and label all these images, right? We don't want to do that. So now we'll go back to our data set and right. Okay. And I will go back overview. Right. So now I'm going to click download this data set. Here you can find it, the downloading data set, right? So once I click that download option over here, it will say show download code or download zip in computer. So now I am going to use show download code. Before that, I need to select the format. So I am going to use YOLO V5 PyTorch. Right. I'm going to use YOLO V5 PyTorch, right? YOLO V5, where is that? PyTorch, yeah. Then I'm going to show download code and click continue. So once you get that thing, you will get a code like this over here. So what you need to do is you will have an API key. It might be different from my API key. So yeah, show download. Huh? No, it's there. Now you have to run this one. Before that, you have to go and get that code. I copied over. You can delete it. Yeah, this block you have this. No. How do you Can you copy this one? You have to paste this. Yeah, you have to delete that one and paste that code over here. Okay, you paste. How do you do command? It's command. Yeah, command. Command. Okay. Command. So now what you need to do is you have to download this, copy this code, right? It might be a different API key for you, maybe the same API key as for us. So then we go there, go to the Google Colab, and I'm going to paste that one over here, right? It's a different API key. Can you see the same API key? My one is starting as CAT, C-A-T. Your one is the same? Different API keys might come. The same API? No, different. Yeah, because it's person to person different. It gives. So you can access this database through this API key, right? Now we'll execute this one. So what is going to happen is it'll download the data from the RoboFlow directly and put it into my vehicles folder. See, vehicles 2. So data set is put over here. Test, train, validation, and everything is there. So now I have downloaded all the data set to my environment. Did you execute it? Yeah, cool. So once you execute, you can go under the YOLO 5 folder. You can see the vehicles 2 is added over here. Now we are good to go. So now we are going to train the YOLO. So as we already know, when you want to train, what are the important parameters that you have to specify? The first thing is the logs function. Second one is what is the batch size. Batch size means what? You have 1,000 images and you select random batches and do the training, right? And the other one is epochs. What do you mean by epochs? How many iterations you are going to run the training? And data and the weights and cage. So these are important things. But importantly here, unlike the typical CNN way that we have trained, because we have built up the model last time by ourselves. We have built up the CNN layer, convolution layer. We have built up our thing. We have defined the loss function. We have defined the optimization function by ourselves. But now we don't have that freedom because we are going to use some others model, which is YOLO V5. We have to restrict to their model parameters. We cannot do anything else other than the image size. The image size, we had defined it as 640 earlier when we are exporting. And the batch size, let's say 8, we have the freedom to change this. And the epochs 10, right? I can change this to 100, 200, anything. But I will keep it as 10 because otherwise it's going to take a long time for us to do the training. Maybe let's do the training for 20, let's say 20, right? It won't take much time, I believe, because it's going to see in the thing. And the rest of the code is the same for any YOLO training. So this is a fixed code that we have to use for the training. The only parameters that we can change is the image size. So we have downloaded the image in the 640 size, if you remember. And the batch 8, batch means how many these total images are going to be divided into 8 batches. One batch is going to be randomly picked for the training. So I'm going to run 20 iterations for the training. Then once you click this run, then the training will start. So while before running the start, this is a code for the YOLO V5. It's not the typical training code. Since we are using their thing, we have to use this thing to do that. Okay. So it downloading all the things. So this is the model. So you can see these are the model arguments and these are the convolution layer, first convolution layer, second convolution layer, and common C3, there is maybe a max pool, and common convolution layer, and these parameters and everything is listed over here, right? Basically, it's a pooled up convolution layers arranged in certain manner to detect the data. So how they have came up with this? They have experimented with several models. Out of these models, this model showed a better accuracy. So they uploaded this architecture into that model where we are accessing that freely, right? It's an open source thing. So we can clone it and use it in our environment. So now the training has started. So if you see epochs 19/2 that I just ran the 2 epochs earlier. So it's execute the epochs number, GPU memory, right? 1.78 GB is utilized for this training right now at this moment. Box loss. So the loss associated with the bounding box regression. So we have the bounding boxes created. So that is related to that. We don't want to go into detail about these things. So we know how to collect the data, how we use the YOLO v5 to train the model. Then we can use that train model to do the testing. That's all we need. Let's see how that works. So now the training is happening. We have to wait for a certain time. So per batch, we have divided the whole image into 8 batches. So per batch, 330 images are selected, right? So now the input, as you know, image and the text file, where the text file has the labels and the box points, right? So that's how we do the training. So it's not limited to this application. It can go beyond this thing. So there are many other object detection methods available, but YOLO stands the best among all the things because of this superior nature in detection, and it's faster compared to other methods. Why? Other methods scan through the box. It takes time, right? This look only once, close your eyes and tell. That's the thing, right? So you look only once. YOLO. That's the definition. So you look only once and you tell what are the objects there. So that is a different architecture that they have came up with, right? So when as a machine learning engineer, so if you want to go into research R&D, research and development R&D, you have to work with these kind of, you will build up the models like this, right? But if you are an engineer, you do not need to. What you need to know is, to do this task, this is the library I'm going to use. To do this task, there is an open source library available. I can download and do it. So Parallosier, I told you, that's the name I know, right? I have worked in it. I never built it. I don't know how they do it, but I download it and I use it as a tool. So for the object detection, YOLO v5 is there. We are going to use it. So at this moment, as an engineer, you do not need to know what is the architecture and everything to the hardcore. You should know to a certain limit to understand. But with this YOLO v5, now you can do any training. You know how to do the data collection, how to do the training, and you can do the testing, right? So that's how the machine learning engineering job works. But if you go to the research and development, you have to build these models. That's a different story, complete different story. That lot of mathematical computation power, like a lot of maths, it's really hard, right? So at this moment, as an engineer, as a AI application person, knowing the library is more than it, right? So that's the aim of this class, introducing to the libraries and make sure you are building your own models, right? So the advanced classes, maybe Para is planning in Dubai. So that will have an impact on deep diving into certain models. For example, if I want to teach YOLO, that itself need 10 classes, right? How the mathematical modeling each layer works, how they do the neck, how they know the head, everything. It's a painful process. So it itself, YOLO can be one subject. So we don't want to waste time. So we'll use the existing model, right? So after this, if we get time, I'll go through briefly through the face recognition stuff. Then next class we will start, and I don't want to rush it through to finish it, right? So next class we can start and we can do the face recognition and also emotion recognition, right? So let's see the object detection now today. And the face recognition, as I told earlier, there are a couple of ways that we can do. One, I take my face image in this angle, this angle, this angle, top angle, and this view with beard, without beard, with specs, without specs. Lot of angle I can collect Logi data set, right? And I can crop the face. I can crop the face and Logi database, right? And you can select your friends. My wife's name is Mayu, so Mayu's data set. So then my kid's name is Rayu, Rayu's data set. Like that, I can collect images, maybe 100 images of a person with different colors, different lighting, different angle, right? So now it's a data set. So now if you have different data set, what you can do? You have put it into the label and you can build your own CNN and you can do the training, right? As we have done for the handwritten character recognition. We had images, we implemented a convolution neural network, we did the training to classify the number, right? The same approach we can take, but it's a labor intensive step. Imagine you are going to go and say, I'm going to build up a face recognition system as an authenticative app to come into this SIST building, right? So once you come in, it will check your image and it will open the door. If the face is not recognized, it will not open. So imagine I am going to collect my data. So I go in front of different angle, 100, 200 images. Is it a feasible option to get the, no way, right? So you are going to a gym, the gym guy say, okay, stand in front of, I'm going to take 1,000 images of you. No way, it's not going to work, right? So then how we implement? That is one way. CNN we can approach, but that thing needed a lot of data. So you can't go and collect data for a gym. You go to the gym and spending 1 hour to select 100 photos, not feasible. So with one photo, how we are going to do that, right? So that is another library called face detection library that we are going to use. It's an open source Python library itself, where it's a CNN based library. Again, they have built that library in certain ways. Once you upload the image, it will detect the face. How we detect the face now? We are training it for now, right? So in a picture image, I take a class of this image, face. I label the faces only, right? Then the model knows how to detect the faces, right? So once this detected, it will be detected. But the face recognition model does not detect the face in that approach, because that face recognition model came a little bit earlier, before this YOLO and everything came up. So they have taken a different approach. That we will learn about that, right? In next class, if we get today, we'll go through that and see. So, but finally, it's a CNN model, right? They have created an architecture which will be able to detect the faces and extract the feature. So that is a library. As a single code, we are going to use that. If you want to deep dive into that thing, it might need 3 classes, how that model is constructed. So that comes under R&D. Right now, we are trying to be an engineer. So, or the application person. So if you know what are the libraries, totally fine. Right? So I'm talking about this YOLO and everything. It's slow, comparatively slow and everything. But the new trend in AI is large language models. Have you ever heard about large language model? ChatGPT is a large language model. Gemini is a large language model. Now the large language model can do anything. Even president is going to create an AI movie in Sri Lanka. I think after the election is going to start. So I'm going to be in that movie task force as well. It's funny because we have a lot to spend on many other stuff, but they want to make an AI movie. But anyway, it's a good, I don't know, maybe it's a good approach to make some people to know how to do AI tasks. So through this, there are a lot of students will be gathered and they will be trained on AI. That task force maybe can be used to do many other applications, right? So, but they are going to start an AI movie in Sri Lanka, right? So I'm one of them. And AI Club already it's introduced. Introduce mean they are going to introduce, but due to the election talk and everything, we submitted the paper, concept paper, but still it's delayed. So in that case, grade 9 onwards, students will have learn AI in the new syllabus. So that's a very good approach. So I was there in the committee. Yeah, but it takes time. It's not easy. Election, money, but Microsoft sponsored a certain amount to introduce AI into schools. So they are sponsoring their VM facilities to do the training and testing. So that will be amazing. once it comes up. So all the countries are looking forward to change. So I will show you. These are the objects, right? We are training hard and spending the GPU power. Even the accuracy will go low. Very hard. Okay, I'm going to show something interesting. Let it train. Let it train. Okay. Oh no, maybe no. I'll not keep it. Let it train. I'll go back here. You also let it train. Go to Gemini. Gemini. Right. Right. Gemini has an option. Chat with Gemini. Oh, thanks. Okay, I need to click agree. Use Gemini. Okay, no. Continue. Gemini is the Google large language model, right? So yeah. Yeah. So now I'm going to upload an image, right? Upload an image. Maybe I'll upload this one. This is an image. Then what we need to ask is, it's a complete different approach than the object detection, right? Right now, what we are learning, this is the approach taken in 2017, 16, 15. After this ChatGPT came, 2023, the complete AI landscape is going to change. Now I have uploaded the image. I'm going to ask, let please, like you give an image to a human, ask, identify the objects, right? Identify the objects in the image and explain what is image is. 1, 2, 3, 4. You can count the seconds, okay? It won't take much time. It'll give an amazing answer. The image you send me is a living room interior. The most prominent objects in the room are green couch. It's give the color also. A wiki chair, a fireplace, and a ceiling fan. There is also a coffee table in the front of the couch and lamp on the side, table next to the wheelchair. Overall, the image depicts a comfortable, stylish living room design. Objects are identified. This is not YOLO. This is completely different architecture, transformer-based architecture, LLM. So that we will learn at the later stage, 16, 17 thing. So hereafter, YOLO will not be used because it's slower. Yeah, but you should know how the things work, right? So that's why everything. But still, the face recognition detection cannot be used. I'll show one example, right? I'll put Cecil sir, okay, Professor Cecil. Do you know who is he? Maybe we'll see whether it's detect the face and identify the person in Google. Sometimes it blocks. Sorry, I can't help with the images people here because it's a violation. So they have put it as a violation. So if any people face are shown in an image, it will not do image classification, right? So that's the thing. So now it's capable of doing, but they have restricted it not to use it, right? So it will lead to a totally different world. You can upload an image of me and find a similar person like me in the world. You can find that similar person who is living in somewhere else, get that person to Sri Lanka and get all the bad job to do, and he's doing it. It's me. Anything. It's a simple example. It's like a lot of bad example can happen, right? So that's why they have restricted it. So, but we can do it. So that LLM is the future. LLM is the future. I tried for the Australian company classifying whether it's suitable for a hospitality venue or not hospitality venue. Do you remember I showed an example? Right? So I tried first ResNet. It's an image classification model. I trained for days to get that accuracy. The accuracy was around 0.8%. Right? And I trained the YOLO model to identify whether chairs, tables, car parking spots, and everything. Trained a week, collected object 3 to 4 people, label the images, collect all the objects, use the existing image libraries and everything, train the YOLO for weeks, get the YOLO model. So then when you input the address, Google will search the address, find out the address, send it through the ResNet. The ResNet is an image classification model. I trained on my own data set, right? Then it will say whether it's suitable for hospitality venue or not. Then that image will go through the YOLO algorithm. YOLO model will say what are the objects identified, whether chairs, tables, car parking spots, food-related boards are there or not, everything. Then finally, the decision will be made whether this is suitable for a hospitality venue or not. This took me a lot of time to train and testing, maybe close to 2-3 weeks. And the accuracy is low. Plus, I need to wait for 2 to 3 minutes to get the results because it's not need to go through the YOLO, need to come through the ResNet, then come through the YOLO, then come the decision. One decision will take 2 to 3 minutes. The client said it's very slow. We can't go with this because when the submitted on the spot, I need to give the results. So maximum delay that we can have is 30 seconds. You know what I did? LLM. No model, nothing. Upload the image, ask the question, is it suitable for a hospitality venue? That's all. And it gave the answer, gave it to the Australian clients. They are happy, we are happy. But yeah, that's how the future is going to be. Right? So, and it says, you know, this address belongs to Australian address. And this building image seems to be a residential area. According to Australian law, business cannot be accommodated in residential buildings. Then the client was shocked how the AI model knows these Australian laws. See how accurate it is. If I do using the ResNet, YOLO and everything, just suitable or not suitable. Now the reason this gives is mind-blowing. One time it's a pets barn. Pets barn is a pets item selling store. But if you look from the outside, it looks like a very big restaurant, right? Only the pets barn board is there. When I trained the model, they uploaded the pets barn. I uploaded the pets barn shop, and it said it's suitable for the hospitality venue. It's completely wrong. It's not suitable because it's a pets item selling store. But when I put it in the LLM, the answer was this is not suitable for hospitality venue because this is a pets item selling store. Reason, right? So that's the power of LLM. So this is one example, right? So earlier, when I want to summarize a document, I read and everything. Now I just go, this is an image you can upload. Similarly, if you go for paid version, you can get two advanced version of Gemini, 2 months free advanced version of Gemini. You can go and enroll for that. Then you can upload a PDF, ask questions. Studying will be very easy. You want to summarize, need to find some answer, upload the whole PDF and ask question, will be able to answer. So LLM is going to be the future. So we are going to learn in this course about LLM, how the generative AI works. You are going to build your own chatbots, own PDF reading profiles, and everything will be covered in this class. But once we finish this class, there will be some other new thing comes up. So it's moving very fast, very fast. In last year, this capability is not there. 2023, image analyzing capability is not there in the LLM. They trained it now. Now video analyzing capability. It making videos, it making images. So it's I don't know what is going to happen. It's going crazy. So anyway, we should know what is going on. So now this training process is not at all necessary. But what is the point then? Right. So the question is, now you are using a Gemini free version. When you work with the software, the Australian image classification software, you have to pay for each inquiry. So if I am asking this image is suitable for this thing, I'm sending this image with a question to the ChatGPT. ChatGPT is responding with the answers. So for that, I have to take a payment, which is not much, $0.01, $0.05 per 1 million tokens. So maybe you can ask about 1,000 images within $15. Not much, but still there is a payment. But YOLO, completely free, right? It's an open source model, completely free. But the issue is it's slow. And you should have a higher GPU power environment to make it fast. And the more you train with the more data set, the more accuracy you are going to get. So the training takes time. So either you want the fast results with minimum training within quick response, LLM is the best way to go. So ChatGPT is one LLM, Gemini is one LLM, Llama, Code Llama is another LLM released by Facebook. It's specifically trained for coding. It knows Java, it knows C++, whatever the language you name it in the world, it knows in a very high accurate manner. ChatGPT knows, but ChatGPT is not specifically trained for language, right? Computer language. But these languages are only specifically trained for computer language. Code Llama, those are superior in code. So you upload a code, ask to change the code to do this task, it will do it in a one shot. But ChatGPT will do. When you run it, it might give an error. You copy paste the error, get the correct code, copy paste the error, get it. Finally, it will be okay. But Code Llama will be very superior. That's what they said. NVIDIA CEO said, don't learn programming. Right? Don't learn programming, it's waste of time. So now the problem is the next year graduates from all the universities who did computer science, they are going to face a huge trouble in finding them. Or to a university usually gets a lot of job opportunities for computer science before the degree finish. I heard this time, still there are students without them. All credit goes to the AI, right? So what they are doing is they are running the big companies with interns. So intern can perform up to a level of a senior engineer with the help of AI. If you hire a senior engineer, you have to pay 5 lakhs, 6 lakhs money, right? Minimum. But if you hire an intern, 30,000 rupees, that guy is happy to work on a project to gain experience. 30,000 rupees with ChatGPT help and Gemini and all the language model help, company is making profits, where the engineers are having trouble to find the job in Sri Lanka. That is the scenario in the market right now. So that coding should, it will be accurate. We need to know the coding basics. So when I read the code, I should understand what is there. But I don't want to go sit and code and troubleshoot. No, it's going to the Code Llama. That struggle is going to the Code Llama. But in certain times, Code Llama also struggles to fit the bugs. Right? It's LLM. So then a super senior engineer should be there. For example, in the future, software companies run with 10 senior engineers and 20 junior engineers with 30 interns. Now, 2 senior engineers, 3 engineers, and 40, 50 interns. Then they can manage the whole job with high precision, right? So very easily going to convert. So knowing the code is important. Reading the code should be known, but learning 4 years to learn how to code, it's not worth it anymore. So that's what NVIDIA said. Don't learn coding. NVIDIA CEO, don't learn coding. It's waste of time. So that's the issue. But computer engineers not only coders, they manage virtual machine. They do other work also, right? Database management. So they will find the job anyway. But in future, there will be a huge scarcity for the job in software. Near future. Future is not in 10 years. Maybe in 2025, 26, it's coming. So, yeah, I don't know what. Even the AI, now the AI job earlier who trained using this YOLO, I know I spend a lot of time to do that project, traffic project, to direct the data set, spend a lot of time. It can be done simply using an LLM now. So what's the knowledge that I have in the past? Where it's going to help me? Yeah, so that's a question mark. It's going to go as a question right now. I have a knowledge. A superior model came, which performs better than the knowledge that I have. So everyone is going to use it. $15 for 1,000 inquiries. Nothing for a company. Nothing for a company. They are spending 5 people's salary to analyze these 1,000 inquiries in that loan providing company. 5 people's salary is more than how many? Like maybe $100,000, right? 5 people per month. Let's say 6,000 per person, 5,000 per person, 25,000 per month they are going to spend, where it can be done with $15. Right? Yeah, so it's an issue. So anyway, that's not our problem, but the world is moving really, really fast. We should catch up with the world and run, otherwise we'll be left alone. So to do that, you have to get the exposure from outside. Exposure. So look at the YouTube videos, lecture notes by the others. You listen to the guest lecture series of NVIDIA guys, Apple guys. Everything is free in online, right? Facebook guys, AI. So they are releasing day by day new models. So it's amazing, really amazing. That's why Elon Musk said he left from OpenAI seeing the damage the OpenAI can do to the world. Right? Couple of people have left AI leadership because they have seen the damage that they can do to the world. That is true. 100% it's true. We are seeing that, right? All right. So now my training is done. What about yours? Training done? Good. Training done, eh? All done? How many of you still running the training? We will wait for a couple of minutes then. So we'll do the face recognition next class. Right? I don't want to rush it through. So, and emotion recognition also we'll be able to cover to next class. Because object detection is the very important thing in many applications. Many applications. Now after this class, only thing that you have to change is the data set. Rest of the codes are here. Go to RoboFlow, create the data set, download the copy, put it here, then your model is ready to run. You can do any object detection here after this class. Right? So play with it. Go home. If you get time, play with it. And if anyone talking about object detection, you know what is happening in the backend now. Right? So that's the important thing. All right. So my training is done. So you can see what are these training parameters, blah, blah, blah things. Still I have run only for 20 epochs. 20 epochs is nothing for an AI model, right? So it should go more than 1,000, 2,000 epochs and 100,000s of data to get the very high accurate model. But now for the class being, we'll do that. So what we can do is now this train model is stored under the YOLO V4, runs because it's told me runs train experiment. Results saved to runs train experiment folder. So I go to the runs train experiment folder, right? Experiment folder and the weights. I can see two models, last.pt, best.pt. So what is these two models? Right? So while doing the training, you know the loss function. It starts from here, right? There are function. It go down, and sometimes it can have a high value also. It can happen, right? Because the weights are adjusting. It's going down, going in the right manner. Then certain weight change will increase there. Then the model will change it again and come down and go down. It should go in the downgrade button. Certain time, this will be a high image. So we don't know when the high thing happens because it all depends on the weight change. So what is going to happen is we need to save imagine like we are coming down and another thing is higher. So now I am doing first iteration, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20. Let's say like this. So now, what is the best model you think which give the right output? So right at this moment, we have the low OLS, right? Low OLS value. So this is the best model so far. These weights are the best weights. But after that, I am training and going. But I didn't find the optimum. After that, it will go down again, right? We don't know based on the iteration. So I'm doing 20. Out of that 20, I want to make sure I need to get the best one. So as a typical practice in any training, what we do is we save every iteration weight, right? So for example, when I am training, I just save this weight as best. Best.dt. In this case, best model, right? I save the model as best. When I come into the second, I check whether the first loss is less than the second one or the greater than the second. If we see the first one is greater than the second one, then I will replace the best with this one. Right? I'll erase this. I'll delete. When I come to this point, I'll check the third iteration. The loss is, error is less than the second one or greater than. If it is less, I will erase and put it less. Right? Like that, I will come back. Come here. I put here the best one, right? Best one. Then I go here. Now what is going to happen is the loss is higher than the previous one. So now I will not replace this one because still the best is this one. Right? I will keep this best. Then I'll go to the other iteration, check. Still this loss is higher than this loss. So this is the best model for me again. So like that I will go. So like this, and the best model will be saved at the better point. Right? But I'm training every model and I'm saving. So that is the last training, 20th iteration training. Right? So that is the last PT, and the best PT is where I got the minimum. So this is the standard typical practice. Why we need to do this? Because we don't know where, which iteration we will get the best weights combination. Right? By doing this, based on the loss, I save the best model when the loss is less. Right? It can go up after that. I don't care. But this is the best way. Randomly, when the AI is saving the weight, I got the best model. I saved it. So once I save it, then I can use that best model to do the testing, troubleshooting, everything. Right? So now the model is trained. I can download the model to my computer by executing from this thing. Okay, I'm going to download the best.pt. Best.pt. When I click it, it will download the model. Okay. And you can use this downloaded model in your application locally, right? You can locally code it in the Python, you can run it, and you can test what other objects have been detected in that image. So last class also we have trained the model and we have saved the model as a .h file. This is .pt. There are different file formats for each model. Yeah. It's not designed for AI. It's a coding platform by Google. But the good thing is when the AI came into a market, they have introduced a free GPU for a certain time limit. So when you are using it continuously, it will stop at a point. Then it will connect after 1 day only, right? 20%. Llama is a large language model. No, Llama is a large language model like ChatGPT. So we can use the Google Colab to access the Llama and get the output. Llama is a model, large language model. Google Colab is a coding platform with the GPU. So that's the benefit. Jupyter Notebook that we have learned in the Python, that is a coding platform, but that doesn't have a GPU. That's run with the CPU power. We do not, because I have written all the codes which is needed. So now you can build up the projects by plugging this code here and there and make the project. Yeah, the code is there. Yeah, so we do not want to know the coding, but we should know what is happening inside. That's why we learn the basic codings like for loop, if loop, and everything. And if you go through these individual codes, you will be see the definitions, for loop, if loop, import libraries, all are known codes. We should know what is happening. That's why the 3 basic Python classes were done. But in this class, continuously, we are not going to code. We are going to execute the code. So if you want to build the project, you know what code which does what. So you can plug and play with the codes and you can create your own projects. All Python, all Python. Yeah. Python is an open source language. I don't know. Yeah, I have downloaded it. So I can go back to the thing. I can see it over here, best.pt. So right now I can load this model and I can do the testing. So now let's do the testing. So what I have the best PT, content, YOLO v5. I have saved the best PT over here. So I can torch.hub load. I can load the model and I can test it. For testing it, what I'm going to do is I'm going to upload an image here. Let's see whether it works or not. Sometimes the Google Colab have an issue to visualize the image. Now let's see. May I give an error or may I give a result? We'll see. Yes. So this image is having an issue sometime. So this code will run in the local environment. So now what I have done is I'm loading the image, loading the trained uh, model from the YOLO v5, and I'm saying, okay, this is the image. Now identify the objects. So now it's giving an error saying resizing the image failed. Please check the image path and format. So let me upload another image and check for it. No, we'll download another. Vehicles, HT vehicles. So this is a Google Colab platform issue because they are not allowing us to access the images which are uploaded into this Google. So video is might be restricted. So video, maybe it might be. Let me see whether this image works in Google Colab. So you have to drag and drop. Copy path, then you have to replace that path with this one. And let's run it and see whether it's resizing or not. Sometimes it's an issue in the Google Colab. See, resizing image fail. It's a issue with the Google Colab, but if you get this thing and run it in your local Python, it will be able to run. Okay, so this is the code for that. So once you upload the image, you'll be able to see how your model performs in the image. So let me try a couple of other images as well. Sometimes it works if we are not using an open source image. Do you have any images on your phone that is taken with the vehicle something? If you can have it, then you can upload and try. That might work. Because there's Google blocks to use these open source images, like in their platform. So let me see that I have anything. Can try with few images. Let me try with this one. Mhm. So there is an issue in this Google Colab, but it worked in my thing. Okay. So you can try it out, or I will try to fix this one by next class. Resizing image. Yeah. So it's giving an error message related to the image. Okay, cool. Give me a second. Yeah, I got it. What's the issue is I need to put this over here. No, it's giving the same error. Okay, never mind. So trained. mm, Yeah, some library issues. I will fix that one. Try to. But this model will be working on your local thing. So now you know how to do the data collection, how the model object detection works, and how we have trained it, then how to save the model. Only we didn't test it, so I'll fix that issue. Maybe this Google Colab frequently do some upgrades. So when they do upgrades, certain libraries will not support. So, but this is not a library issue. It says it cannot find the image. So, but the image is over here. So I don't know the reason why it's saying that, but we'll be able to fix it by next class. Okay. So with that, we will make a, we will conclude the today's lectures. Any questions? Any questions? Yes. For that, you have to install the Python. After that, you have to just copy this code, execute. And the best py you have to change. Right now, what I do is I just got this thing from this saved model. So now you have the downloaded model. So you have to give the path to that downloaded. Right? You here copy as path. Right? Click and you can put it there and the model will be loaded into your local machine. And you put the image and you run it. Okay? Clear? All right. So this is a resizing is failed. Some issue is there in the resizing. So we'll be able to fix it. No worry. All right. So next class we will be learning about the face detection and face recognition. So we will be learning about data collection and labeling, again using the library. We are not going to train a CNN model. We are going to use a CNN model which is existed in the environment. Okay, cool. All right. So, any questions so far? Okay, now you got the point how the model works and how to collect the data. Do you have the confidence to train a model now? Right? You can do it, right? Right. Okay. Go home and practice it again. Go through this thing. Try to train a model maybe on some practical car data is there. You collect maybe 100 images, label it, and try to do the training. Testing this code, I will try to fix this one. Earlier it worked. Now it's having an issue over there. Okay then. See you until next week. Okay. Bye. Hold on. There is an attendance sheet. I forgot to do. Cannot find it. Can you hi Dara. Yeah. I'm looking for it. Let me see. I couldn't find. I get it back. Did I get it back last week when you were here? Yeah. I couldn't find it. I will get it next week. Yeah, we can see who I have looked at. Yeah, I'll get it. Yeah. Okay. All right. Thank you. Bye. See you. So once you go back and load this one, these things will be go out, because it's a temporary location, right? So that's why I said you have to download it and keep it to do the testing. Then you can load it and put it over here and you can do the testing, right? So once the training is done, you download it and keep it here, right? So then when you want to do it again, you want to do the training, do the testing. So what you can simply do is go there, copy, drag up here, and once it loaded, copy that path and replace it over here. Replace it over here, and you can do the testing. Okay, so you don't want to run the training again from the beginning. All right. Okay, then. See you. Bye. So YOLO V5 is a fairly older version. There is YOLO V10 also. So you can do the testing with that YOLO V10 and everything. Okay. Yeah. YOLO V10 is the last one. It's faster and it's good in detection.